Hello and welcome to another video. In this video we're going to be going over the number of beautiful subsets. And on this one you're given an array nums of positive integers and a positive integer k. And a subset is beautiful if it does not contain two integers with an absolute difference equal to k. Return the number of non-empty beautiful subsets. And they just tell you what a subset is, but basically, like in this example, so you can't have 2 and 4 together, and you can't have 4 and 6 together. But everything else is valid, so these are the ones you can have, and then in this one it's just 1. So we're just going to be doing the normal backtracking kind of template we've been doing. There is a more optimized solution to this, but it's like a probably very hard problem, I'd say. And I think it's like outside the scope of this. But essentially what we're going to be doing is we're just going to be building subsets, and we're going to be checking if they're valid, and then once our subset is built, we'll just add it to the result and we'll return it. So it's going to look very similar to the problems we did last like 3 or 4 days, and it's like a core algorithm that you want to know for interviews and things like that. So we're going to go over that. So that's kind of what we're going to be doing, and I'll show you in the code. There's not too much to demonstrate. It's basically we're just going to be building subsets and checking when we were putting a number in, does that number have a conflict with any other number in the subset? If it does, we won't put it in. So let's get into it. So essentially all the same stuff as before. So we're going to have a couple variables, class variables. So we're going to have a result, and we're going to have our subset that we're going to be building, very similar to, if you look at the last few videos, this is all going to be the same stuff. So essentially, we can just say result equals 0, and our subset is a new array list. And so we're going to do kind of the same thing where we're going to call a backtracking function, and we're going to give it a couple things. So we'll call backtracking or backtrack with the same kind of stuff as before. So we'll just give it an index of 0, the nums array, and k, because we need to use those things, and just return the result. And then the rest of the time is just going to be spent writing the backtracking function, which all it does is it will build a subset. It'll try every single possible combination of subsets, and then we'll just check if is that subset non-zero in the end. Like, because we don't want to include the empty subset, but everything else we'll have. So this is what we're going to do. So we're going to have a subset or backtrack function. It's going to take an index, the nums array, so this, and then k. And first we're going to check, are we done building our subset? And if we're done, that just means for every single number, we'll just say, can we include it or not include it in the subset? And so once we're like out of bounds, then we're done building the subset. So if I equals nums length, then we're done building the subset. Now we just have to check, is our subset empty? So if subset is empty, so if it's not empty, then we'll increment our result. And either way, we will return. Now, for the current number we're on in the subset, essentially we have to choose, do we add it to our subset or do we not? And in order to add it, we have to check our subset and make sure there's no conflict with this number. So we'll just say, like, let's go through our subset and let's just check, is there a number in the subset that has an absolute value that when you subtract the current number we're trying to put in, we get k. If there is, we can't put it in, so we'll exclude that choice. But if we can, then we'll try both, and then we'll always try not including the number. So essentially, you have 2 to the n kind of choices as before for the subset. For every number, you have a choice to add it to the subset or not. So let's first make a Boolean value, and we'll call this like valid, and we'll say it's true. And then let's go through our actual subset and check, is there a conflict with the number we're currently trying to put in? So we can say for int cur something or num in our subset, if the absolute value of that number minus the current number we're trying to put in, which is just nums I, equals k, that means we can't put in this number. So if we can't put in this number, we'll just make valid false, and we'll just break out a loop because we don't need to check anything else. If there's one conflict, that's all you need. So now basically we need to check, did we go through this? Did we go through our subset? And if there is nothing invalid, then we can try to add this current number to our subset. So if valid, then we can try to add our number to the subset. So subset add numSi. So this is the choice of taking the number if we're allowed to. And then we will recurse to the next number. And we need to pass down all the rest of our stuff. So we need to pass down the nums array and k. So if you've been following the videos for the last few days, you can see this is very, very similar. It's all the same. You have a result, you have a current subset you're building. Once you're done building the subset, do something and return. And then for the current number, you choose to take it or not take it. But before you can take it, you have to make sure that it's actually valid to put it into the subset. That's what we're checking here. So we backtrack. Then when this function returns, now we're going to choose to not take the number. So we have to take this number out of our subset. Yeah, so I think you can do like remove last or something. I misspelled. Another thing you can do for this subset is you can do like a bit mask, but I think this is like fine too, so it's not a big deal. And this is like a very standard template that you can use to do all your combinations, permutations, all that kind of stuff. So I think this is like, even though this is like not as performant as some other stuff, this is something that's super reusable and that's like more valuable for like learning interviews and stuff than getting like the optimal solution. So anyway, and the optimal time complexity between the same. Like I said, there's only one way to do it more efficient than this that has better time complexity. I think it has significantly better time complexity, but it's also very difficult. So I thought that was like outside the scope of a medium problem. But anyway, so we're going to try to remove this. And now we will do our other check of recursing. So we can always not include the number, right? And that's what we're doing here. So now we'll try to not include the number and pass down all our other stuff. So essentially, we see, can we add the number? If we can, let's try to include it in recurse, and then let's not include it. And this will give us every combination possible, so we don't need to do any kind of returns, and this should be everything. So let's see. Okay, so like I said, the runtime is slower than like this optimal solution, which is like a dpn log n solution, but that one's way more complicated. So that kind of level problems I'll be doing in like LeetCode contests and like hard problems and stuff. So yeah. So in this solution, let's talk about it. So this is going to be, so basically you have to think about like how many subsets can you build, and it's 2 to the n, because for every number we have a choice of take it or not take it, and we have n of those. So for every number you have 2 choices. And then also we have to actually check before we put in our number, like, can we put it in? And to put it in, that's O of n, because we have to actually go through our entire subset and check, is it valid? So this is going to be like this. 2 to the n times n. And space. So there's a couple things here. To build the actual subset is O of n, because we can like have up to n numbers. And then also the recursive call stack for the backtrack is also going to be O of n, because we're essentially recursing to the next index and the next index and next index, and there's n indices. So both of those are O of n, so this is just O of n. And yeah, gonna be all for this one. I wonder how many more backtracking problems they'll give us, but yeah, hopefully if you followed the last few, you can kind of get the pattern and you should be able to do these problems very quickly. And then from here on in, once you can do these, then start worrying about optimizations. So like maybe how do I cache some stuff, or maybe maybe there's another solution that's not backtracking, which there is for this one you can look into if you want to. And if you have questions about that one, if you want me to make a video on it later or something, I can do that. But yeah, that's going to be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.